Okay, good morning, students. So we are here for the first Zoom consult to revise the Sec 3 topic of atomic structure. Specifically, you can actually find this particular document in your Chemistry OneNote under your personal folder under class notes. So it's entitled JH1. Okay, so June Holidays Lesson 1, Atoms, Isotopes, and Ions. So today, and for the rest of the consultations, how this will work is two ways. One, I will go through a little bit of content first. So you will need to copy down this content summary either on paper or on OneNote itself. All right. So if you're using your iPad for the Zoom, I strongly advise you to actually use paper to copy down the summary so that at least you can still see my shared screen plus write down on paper. All right. Now, after we go through the content, we will go through some of these questions here. You notice that these questions are actually quite essay-based, and that's deliberate. Because for the O-level combined science chemistry, the section B is very, very essay-based. You will need to score in such essay-based questions because it's usually just content. It's not something very, very challenging, so long as you are able to elaborate and give the details needed that is relevant to the question. So today we shall focus on this skill. How do you write an elaborated answer for section B for O-levels? All right. So we are going to start off by talking about atoms. So this is where we'll start some of the copying. So please make sure you have your paper ready or your iPad ready to copy. All right. Now, you have heard about atoms in Sec 1. You know that atoms are very small. Atoms cannot be divided, broken down into something simpler. So this tells you that atoms are the basic building blocks of matter. So what do we mean by matter? Matter means that anything that occupies space and has mass. So all your chemical substances are considered matter. So chemical substances are made of atoms, hence why we need to study atoms. Now, specifically in Sec 3, you had learned that atoms contain subatomic particles. So subatomic means smaller than atoms. So what particles are smaller than atoms? What particles are inside the atoms? There are three types, I'm sure you remember: proton, electron, neutron. All right. These three particles are called subatomic particles, and they differ in terms of their relative charge and their relative mass. Now, you may be wondering, why do we even use the words relative? Why don't we just say charge, mass? Now, the word relative here means I'm comparing. I'm comparing a proton's charge with an electron's charge. I'm not saying that the proton must be a 1 or a 2, all right? It's comparing. So what does it mean? For example, proton is +1 relative charge. Electrons is -1 relative charge. What it means is that the proton is positive and electron is the same charge in terms of magnitude, but negative. So the signs are different. Proton, P for positive, electrons for negative charge. All right. Finally, neutron, the relative charge is 0. All right. Neutral, 0. Okay. Charge. Okay. Finally, we have the relative mass. So this is where you start to realize a bit of a difference in the values. So you notice that a proton has a relative mass of 1, whereas an electron has a relative mass of 1/1840. All right. What this means is that an electron is 1,840 times lighter than a proton. All right. So that's why relative is important. The word relative means I'm comparing. Comparing an electron and proton, an electron is 1,840 times lighter in mass. All right. So this is just a quick revision for you. You notice that for electrons, right, I've given two numbers there, 1/1840 and 1/1836. The main reason is because 1840 is obtained by rounding off 1836 to 3 significant figures. All right. So you will see both versions in the O-levels as well as other school prelim papers. Now, the last column that we should learn is where is it located? These three subatomic particles are not all located in the same place in the atom. So if you recall, protons are located in the center of the atom called the nucleus. All right. Electrons, however, are located in electron shells around the nucleus. Okay, so protons and electrons are not in the same space. Finally, neutrons are also located in the nucleus. Okay, so this is a quick revision of the 3 types of subatomic particles, which we will quickly fill in on our paper, and we'll move on to the next concept, which is crucial for us to answer some of the questions you see. Okay. Now, for those in the Zoom meeting, once you're done with copying down this summary, can you please give me a thumbs up so I know I can move on? Okay, so I think I shall move on to the next concept. So these are the 3 types of subatomic particles in an atom. However, the atoms of different elements are different because they contain different numbers of protons. They contain different numbers of electrons. So how do we deduce how many protons and electrons and neutrons an atom of an element would contain? So the key here is that we will need to be able to link whatever we see in the periodic table to how many protons, electrons, and neutrons the atom of the element will have. So this brings us to the concept of nucleon number and atomic number. All right. So if I were to go to the periodic table now, and I look for an element, take for example, if I look for potassium. So potassium symbol is K. Okay, I'm sure you're familiar with this. Potassium is K, the symbol, and it's found in group 1. If I were to go to the periodic table, I will find 2 numbers. So what are the 2 numbers? You will find that the bigger number for potassium in the periodic table is 39. The smaller number is 19. All right. So even though in the periodic table, it is written with the larger number at the bottom, when we write it out ourselves in an exam, we would always represent the larger number on top. All right. So this is a convention, is a habit of how we usually write it. Now this is called the nuclide symbol. Okay, the nuclide symbol, if you ask for a nuclide symbol, you will basically have to copy out the chemical symbol of the element, bigger number on top, smaller number at the bottom. Now the bigger and smaller numbers have names, and this is where you need to learn the definition of the names. The smaller number is called the proton or the atomic number. Now this is the smaller of the 2 numbers, so please take note of this. Okay, the smaller number is called the proton or the atomic number. So what this means is the number of protons in the nucleus of an atom of the element. So this is the definition for the proton or atomic number. These 2 words mean the same thing. All right, it's the number of protons in the nucleus of an atom of the element. Now, what is important to take note of this is that different elements have different proton or atomic numbers. This means that the proton number can be used to identify which element it is. Just by looking at the smaller number, the number of protons in the atom, I can work out which element it is. It is like the IC number of the element, all right? Because different elements have different numbers of protons. So this is a crucial concept that we will need to know. Okay, so now moving on to the larger of the 2 numbers. The larger number is called the nucleon. Nucleon, or the mass number. So it has to do with mass, clearly. So if you look back at just now, the three subatomic particles, protons, electrons, neutrons, in terms of relative mass, the mass of the atom is mainly due to the protons and neutrons. That's why the mass number is the total number of protons and neutrons in the nucleus of an atom of the element. Okay, so the larger number is the nucleon, or the mass number, which is the total number of protons and neutrons in the nucleus of an atom of the element. Okay. So we have learned two definitions. First definition is the proton atomic number. The second definition is the nucleon mass number. Now, so as you copy down, you have to think and make sense of it. It's called the mass number because the mass of an atom is mostly, largely, due to the protons and neutrons. That's why the total number of protons and neutrons is the mass number. Okay? Now, why is it called nucleon then? So clearly nucleon, this word nucleon comes from the word nucleus. So again, thinking back, which subatomic particles are found in the nucleus? It's the protons and neutrons. All right? So we have learned these two definitions. Now, there's one last definition that I've not included here, but you have learned it in a different chapter, which is mole concept. You have learned that the larger number is what you take if you want the mass, right? So actually, the larger number also has a similar term called the relative atomic mass. Okay, relative atomic mass, AR. It is the larger number that you find in the periodic table. All right. So is it exactly the same as the nucleon number? The answer is no. And the reason why the AR and the nucleon number may not always be the same is because the AR is the average mass of an atom of the element compared to 1/12 of the mass of a carbon 12 atom. So if you look at the definition of the relative atomic mass, there's a very, very key word that I've underlined. That's average. The relative atomic mass is an average. Average of what? Average of the different isotopes. Okay, so we have learned last year the concept of isotopes. I will revise that in a very short while. But the idea is the relative atomic mass is an average of all the isotopes present for that element. So I actually take into account how many isotopes it has, what is the percentage presence of each isotope. Whereas the mass number is just the total number of protons and neutrons. All right. That's why different isotopes have different mass. Okay, so if you just copy down this first, we will come to it, isotopes, in a short while. This is the second part of this chapter already. All right. Okay, once you're done with copying down this part of the summary, can you please give me a thumbs up so that I know that you are done? Okay, and I can move on. Okay, good. All right, so now this part is about definitions, right? Then after knowing the definitions, I need to figure out, okay, now I know that it's like that. So how many protons does it have? How many electrons does it have? How many neutrons does it have? This one, I think you can do it really quickly. The proton number is 19. So it's 19 protons, right? So an atom of potassium has 19 protons in the nucleus. How many electrons will there be in total in the shells of potassium? The answer is 19. So for atoms, atoms, if it's an atom, the proton equals to the electron. The number of protons equals to the number of electrons. And the main reason is because atoms are electrically neutral. All right. So atoms are electrically neutral. What that means is that the positive protons must equal to the negative electrons. Hence, it's 19 as well for the case of potassium. Finally, to get the neutrons, we take the larger minus the smaller, because the larger number is the total number of proton plus neutron. So if I want neutron only, I will take the larger number, the mass number, minus the proton number, which gives us 20. 39 minus 19 equals 20. So this is not very difficult. I think you can easily get this. Okay, you are already familiar with this. But what's more important is, I'm not sure if you have realized, this is an important concept. Because you have learned terms like atoms and ions. The main difference between atoms and ions is that atoms have no charge. Ions have charge. Why? Because in atoms, the number of protons equal to the number of electrons. So this is the key idea. Whereas in an ion, the proton and electrons are not the same number. That's how you differentiate atoms and ions. Okay? And we're going to see that in a short while. So now, the key thing for us in chemistry is always the electrons. We are always interested in electrons because number one, electrons are either lost, gained, or shared during a reaction. In order for atoms of different elements to bond together, they have to either lose electrons, gain electrons, or share the electrons. So it's always about electrons. We're not interested in neutrons in chemistry. All right. So in chemistry, you have to be very, very familiar with how to write the electronic configuration or the electronic structure. So we are always taught how to write electronic configuration or structure, right? So how are the 19 electrons arranged into shells? You already know that electrons are in electron shells. They have to be arranged. It's not some random order. There's a rule to this. The first shell contains 2 electrons, max. Second shell, 8. Third shell also usually 8, right? So 2 first shell, 8 second shell, 8 again for the third shell. This is the maximum number that the shells can contain. All right. So now you count 2 plus 8 plus 8. How many have you actually written? 2 plus 8 plus 8 is 18. But potassium has 19. So if you have written 18, there is actually one more electron which needs to go into the 4th electron shell. All right. Hence, we say that an atom of potassium has an electronic configuration of 2, 8, 8, 1. So the rule here is first shell, maximum 2. Second shell, maximum 8. Third shell, also usually 8. All right. So in case you have forgotten the rules, how to fill the electrons into shells, this is the rule. Every shell holds a different number of maximum number of electrons. All right. We always start filling from the first shell first. The first shell is the smallest and is closest to the nucleus. Okay. Now this is the potassium atom. Now I've written 2881, but you can draw 2881 out. How do you draw it out? Okay, it's not difficult. Put the symbol in the center, then you draw circles to represent shells. 2, 8, 8, 1. All right. So these are different ways to represent the electronic configuration or structure of a potassium atom. But the key thing is, now you got to ask yourself, okay, after you have written this, how does this electronic structure relate to potassium's position in the periodic table? This is always the essay question that's asked. How is this related to potassium's position in the periodic table? So when they say position in the periodic table, what do they actually mean and want from you? So if you think about it, the periodic table is organized in a certain manner. It is organized into groups and periods, right? You have learned groups and periods. So how do you know which group something is from? The number of valence electrons tells you the group. The number of valence electrons tells you the group. So in this case, potassium has one valence electron, one electron in the outer shell. Therefore, potassium is from group 1 because it has one valence electron. So the number of valence electrons tells you the group. So potassium is group 1. The next thing that is crucial for us is the period. So if you look at it, there's 2881, right? 2881. So there's first shell, second shell, third shell, fourth shell. So the number of filled electron shells tells you the period. So in this case, I have first shell, second shell, third shell, fourth shell. So I have 4 shells in total. If I have 4 shells in total, it's from period 4. Okay? So these two things are how you will answer the question. Explain how the electronic structure tells you the position of the element in the periodic table. All right? Okay, let's take this down first, in case you have forgotten this. Okay, and we shall move on to ions after this. Okay, so once you have taken this down, you have finished taking this down, you can give me a thumbs up so that I know that I can move on to ions. Okay, and that will be the second last thing we'll do today. Okay, now, so we were talking about potassium atoms. We already know how to deduce how many protons, electrons, neutrons the atom has, right? We know the atom has 19 electrons because atoms must have the same number of proton and electron, right? 19 proton means 19 electron. That's the atom. Atom, all right? But now we have to ask ourselves, are the atoms going to be chemically stable? Or are they going to be reactive? We already know from all the chemistry you've learned so far, potassium is super reactive. Potassium is a very reactive metal. It explodes when you put it into acid. It may explode when you put it into water, right? So you know that potassium is reactive. It's not stable, which means that 2881 is not stable. Why is it not stable? From the perspective of the electronic configuration, we already know it's not going to be stable simply because In order for an atom to be stable, there must be a condition, which is the outermost electron shell must be fully filled. So now if you look at potassium, 2881, it has one valence electron. This tells you that the valence outermost electron shell is not fully filled. It only has one electron. Therefore, potassium is not stable as an atom. Potassium atom will not remain as it is. So what is it going to do to achieve the stability? To achieve stability, I must have a fully filled outermost shell. So potassium will lose one valence electron. So we say that the potassium atom loses one valence electron. To achieve a fully filled outermost electron shell. Okay, please try to use these phrase as opposed to a stable noble gas configuration, which is fine as well. But I think fully filled outermost electron shell is immediately something that you can relate to just by writing it out. So at first it's 2881, it lost the one valence electron, it became 288. All right. So the full sentence is potassium atom loses one valence electron in order to achieve a fully filled outermost electron shell. So this is how. How does a potassium atom form an ion? It loses one valence electron. Why? To achieve a fully filled outermost shell. All right. So the how and the why is already listed in this one sentence. Now, the key thing is when you lose the electron, do you lose other things? Do you also lose neutrons? Do you also lose protons? The answer, of course, is no. You only lost one valence electron. You didn't lose anything else, which is to say, I had 19 protons for potassium, right? I didn't lose any of them. It's still 19 proton. However, if you look at the electrons, it's immediately clear. It's 288, meaning 2 plus 8 plus 8 is only 18. You had lost one valence electron. That's why it went from 19 now to 18. Immediately you can see, oh, the proton and electron is no longer the same in number. The electron is less than the proton. Fewer electrons than protons. This means that it's a positive ion. Positive ions have fewer electrons than protons because positive ions are formed by the loss of electrons. Okay? Positive is formed by the loss of electrons. That's why you got less electrons than protons. All right? Now, positive ions are otherwise known as Cat ions. All right, Cat ions, there's another name for it. Now, this Cat ion obviously is potassium, so it's K with a plus charge, K plus. Okay, why plus? Because you lost one valence electron. Therefore, you have fewer electrons than protons. So I think this is not new to you. The key is writing it out as a sentence. Okay, the O-level combined science doesn't test you on things which is just one word answer. Okay, there are some questions like that, but it's not the bulk. The majority will be the essay. You will need to be able to write a sentence out. The potassium atom loses one valence electron to achieve a fully filled outermost electron shell. As there are fewer electrons than protons, it is a positive ion. All right, so something like this. Okay, I believe this is just a quick revision for most of you. I don't think it's very hard. All right, so 288, that's the electronic configuration of a K plus ion. So what you notice is that 288 is a fully filled outermost electron shell. It also corresponds to the electronic configuration of argon, which is a noble gas. That's why we say that K plus ion has the same electronic configuration as an argon atom. Okay. And how do you actually draw the K plus out? It's 2, 8, 8. Okay. Because it's an ion, there's a positive charge. So now you will need to square bracket the whole thing and indicate the charge plus outside the square bracket. All right. So this is the potassium ion. So how do you differentiate ions from atoms? Ions have different numbers of electrons and protons. The proton and electron is not the same number. In an atom, the protons and the electrons are the same number. Okay. Now we will do more on ions the next lesson, which is 2 days later, I think. But this is just a quick introduction and revision to how ions are formed. Remember, ions are formed by either loss of valence electrons or gain of valence electrons. Why? Why does atom form ion? Because the atom wants to achieve a fully filled outermost electron shell. Okay. Now, the last thing we'll do today is on isotopes, which is just a very short chapter. But before we get there, okay, can we just ensure that we have copied down everything? Okay, once you have copied down the summary, can you please give me a thumbs up so that I know that you're done and I can move on as well? Okay, so we just went through how atoms form ions, why atoms form ions. The question is always explain how and why the atom will form an ion. It's 3 marks. So you need to be able to write out the 3 marks, which is basically everything on this screen. All right. Now we're going to move on to isotopes. Isotopes is that this subsection of this chapter, which is atomic structure. All right. So last year you learned isotopes. Your teacher probably told you as well to memorize the definition. So now we're just going to go through the definition once more, but really try to work it out in our heads. Firstly, isotopes are atoms. They are atoms, meaning the protons and electron will be the same in number. All right. They are atoms of the same element. They are the same element. All right. Chlorine, chlorine, carbon, carbon. So they're atoms of the same element with the same number of protons, but different numbers of neutrons in the nucleus of the atom. So this is the key. The proton number is the same, and that makes sense because it's the same element. Because it's the same element, that's why the proton number has to be the same. All right. So what's the difference then? The difference is the number of neutrons is different. Okay. So there are a lot of examples of isotopes. Today we're just going to do one, which is chlorine. I think you're already familiar with chlorine. So chlorine you can find in the periodic table. Now chlorine has 2 isotopes, and these are the 2 isotopes, right? Immediately you can see, okay, so the proton numbers are the same. The proton number is both 17. Remember the proton number, the atomic number is a smaller number, right? 17. It's the same. So they have 17 protons, 17 electrons. So the similarity between the 2 isotopes is that both have 17 protons, both have 17 electrons. right? That's because the proton number is 17. So the atoms will have 17 protons in the nucleus. The atoms also have 17 electrons in the shells. So now we're going to decide 17 electrons means the electronic configuration is 2, 8, 7. Right? So these are the similarities of the two isotopes in terms of their atomic structures as well as the electronic structures. So obviously the difference is to do with the neutrons, right? The numbers of neutrons are not the same. So the difference, of course, is chlorine 35 has 18 neutrons. We get 18 by taking 35 minus 70. While chlorine 37 has 20 neutrons. So this is the first difference in terms of the numbers of neutrons in the nucleus. So because of this, because of the difference in the number of neutrons, 35 chlorine 35 is written as chlorine 35. Chlorine 35 has a smaller mass than chlorine 37 because chlorine 35 has 2 fewer neutrons. Okay? So just by looking at the differences and the similarities they have written down, it's quite immediately obvious. This tells you that they have different mass, right? So mass is a physical property. So isotopes have different physical properties. For example, density. Density is mass over volume. So mass is different, then density is different. Density is different, mass is different. Okay, besides that, melting point, boiling point, also different. Okay, melting and boiling points are physical properties. All right. But just by looking at the similarity, which is the number of electrons, it has 287. This tells you that isotopes have the same chemical properties. Right? Why does it have the same chemical properties? Chemical properties means how does it react? It reacts by losing or gaining or sharing valence electrons. So the idea is it has the same chemical properties because the electrons, specifically the number of valence electrons, is the same. All right. So you must always link these together. The chemical properties, the reactions that something will undergo has to do with electrons, usually the number of valence electrons. Okay, so in this case, isotopes have the same number of valence electrons, therefore they have the same chemical properties. However, in terms of the mass, it's different because they have different numbers of neutrons. So because the mass is different, the physical properties will also be slightly different. Okay? So these are two isotopes of chlorine. Now the two isotopes of chlorine, they are present in different proportions. Now this proportion you don't have to memorize, is given to you in an exam. All right, I will tell you that chlorine 35 is 75% abundance. Or I would say the percentage abundance of chlorine 35 is 75%. This is given to you, all right? But the key thing now is after giving this to you, the percentage abundances, can you work out the relative atomic mass? Remember, relative atomic mass is an average. So you have to multiply the mass, which is 35, with the percentage. Similarly, the other one, 37, must be multiplied by the percentage, 25%. And that gives you 35.5, which you can clearly see is what is on your periodic table. It's not a whole number. Why is it not a whole number? It's not a whole number. And this is because it is an average of the masses of the two isotopes in different percentage abundance. Because the chlorine 35 and 37, they are not equally abundant. Hence, when you take the average, it's not a whole number. Okay, so I've basically summarized quite a lot today. I've summarized the whole atomic structure together with how ions are formed. All right. So now can we just quickly finish copying this, and we'll just quickly go to some of the questions, which will give you a flavor of what to expect in the O-levels itself. Okay, so once you have finished copying this summary, again, give me a thumbs up so I know you are done and I can move on. Okay, so as I mentioned at the start of today's lesson, we will go through the content followed by the questions. Sometimes the questions could be quite a lot. Therefore, we will not be able to go through every question. But the idea is for you to practice writing it out based on the content that we have gone through. Okay? Even if we do not manage to go through all of them, you can still practice on your own, write it out. Maybe you can send it to me via WhatsApp or ask me in person as well, so that I can comment on your answer and see whether you have gotten the full marks needed for that particular part. So if we refer to the questions for this particular chapter, okay, you can find this in your OneNote. You can see that these are actually a lot of marks. Just look at question 1, A, B, C. If you add up, it is 10 marks. And this is typical. All right. This is what the last 3 questions of your O-level paper will look like. It looks like an essay. But when I say essay, do you really need to write 3 paragraphs for each part? Just look at 1A. 1A is just a definition. Explain what is meant by atomic number and nucleon number. This is just a matter of studying the definitions, and that's 2 marks already. Right? 1B, explain what is meant by isotopes. So again, it's a definition of isotopes, which we just went through. The isotope definition is 2 marks, followed by deduce if isotopes will have similar chemical properties. Now, the word deduce means it's not just telling me, oh, isotopes have similar chemical properties. You cannot just tell me. You must explain with reason. So isotopes have the same chemical properties because they have the same number of valence electrons. All right. So this 4 marks is not impossible to score. In fact, it is very easy to score. Right. Finally, part C, sodium has atomic number 11, nucleon number 23. Explain what these numbers tell you. So again, it's quite clear cut, right? It has 11 protons in the nucleus. It has 11 electrons in the shells. It has 12 neutrons in the nucleus. Moving on, you should tell me the electrons, 11 of them, how are they arranged into shell? 2, 8, 1. That's how you get the 4 marks. All right. So really question 1, even though it's 10 marks, you're not looking at something that's very difficult to score. And this is the reason why, by knowing the content well, you should do very, very well for combined science, because the questions are like this. If you look at question 2, again, it's about isotopes, right? Explain what these numbers indicate about the atomic structures of the 2 isotopes of bromine. So in this case, the question has not given you the proton number of bromine. You need to go to the periodic table to look for the proton number of bromine. All right, which is not impossible to do. I'm sure you can do that later yourself. All right, the proton number of bromine is 35. So it's 35 for both isotopes. All right, Ken? So you can see question 2A, B, C, again, is not something that we have not gone through. It's just entirely about isotopes. All right, and again, how many marks is that? 10 marks. It's 10 marks because the final question of your O-levels is 10 marks. And you have to do 2 of these questions. So it's 20 marks, just simply like this. All right. Now, question 3, using sodium as an example, explain why the atom of sodium is electrically neutral. So that's what we went through, right? Electrically neutral means what? The numbers of protons equals the numbers of electrons. But you have to use sodium as an example. So this is the key. Whenever you see words like this, using something as an example, by considering some atom, some chemical, it is crucial that you must refer to sodium in your answer. That means you cannot just say in general terms, oh, number of proton equals number of electron. These general terms. Because you need to use sodium as an example, you must quote the exact number of protons and electrons. Sodium has 11 protons and 11 electrons. As protons are positive, electrons are negative. Therefore, sodium atom has no overall charge. Hence, it's electrically neutral. All right. So quoting the number is important. You will see this very often in O-level combined science. All right. So recognize such phrases, apply accordingly. You cannot just say in general terms. General terms, no marks. You need to use sodium's exact example. How many protons does sodium have? How many electrons does sodium have? Next, explain how and why. Even without me bolding the and, you need to know that, okay, so this is all about how an atom forms ions, right? So you need to be very, very familiar with how. In this case, it's sodium. Sodium loses 1 valence electron. But why? Why does it lose 1 valence electron? Again, like I mentioned just now, it loses 1 valence electron to achieve a fully filled outermost electron shell. All right. Ken? So up to question 3, I feel it is mostly doable for all of us. Now, you can also try question 4, but I've not gone through ionic compounds today. I intend to go through it the next lesson. All right. Question 4B will require you to revise ionic compounds and their properties. Okay. But up to question 4A, you should be able to do most of it just based on the content that we have done today. All right. Okay. So I hope you have seen a glimpse as to how the content can be applied to answer such extended essay or section B questions for your O-levels. You will need to try to give as much detail as possible, learn as much content as possible so that you are able to score better in those questions. All right, so that brings us to the end of today's lesson on atoms, isotopes, and ions. Before we end, let me just say also that it's vital, it's very important that you revise what you have copied down, practice through all these questions, and WhatsApp me your answers. You can take a picture of what you have written, take a screenshot of whatever is on your iPad and send it to me so that at least I can mark through all your questions. Okay, that's the best and most effective way to learn and revise. Okay, no amount of listening to me alone will help. You need to practice writing it out. Then at least you learn how to memorize better through that. Okay, so that's the end of today's lesson. We will meet next lesson, which I believe is on Thursday. All right, so on Thursday, we will go through ions and ionic compounds. Okay, so thank you. I shall stop the recording now.